Guten Morgen. Vor 20 Jahren konnte ich ziemlich gut Deutsch sprechen, aber leider ist das jetzt ganz eingerostet. Also, thank you for putting up with me speaking English. I just want you to know I'm not a bad European. Cool, we have some slides. You just kind of like everywhere I go, I have to apologize now. We're in Europe, you know, I'm sorry, it's not my fault. Anyway, okay, let's talk about IoT. Hello, thank you for having me here. It's lovely to be here. I've kind of already been introduced, I suppose. I've worked in UX for a long time. I was always interested in systems of multiple devices, multiple interfaces, service design, that kind of things. For the last 6 years or so, I've been working in connected products, Internet of Things. Not terribly keen on the term Internet of Things, but it's kind of stuck, so I'm going to talk about IoT. I hope that's okay. I'm, as you know by now, I'm particularly interested in connected home technology. Most of my experience is in connected home technology, energy management, that kind of stuff. And I'm the lead author of this book, and I have some copies to give away. So are a reasonable number of you on Twitter today, or can be on Twitter today? Yeah? Okay. Some hands, some not hands. I was going to do a Twitter giveaway, so if you have a Twitter account and you're interested in a book, maybe get ready towards the end, and perhaps we'll figure out an alternative if there are people who would like one who are not on Twitter. Sorry, I can't see very well here. Can I just ask, who here works on software products and services? I'm expecting lots of hands. Okay, great. Who here works on products and services which also have a kind of physical or hardware component? Oh, cool, lots of hands, excellent. Who here owns some connected products or uses them in everyday life? You know, whether that things that connect to the internet that are not a smartphone or a PC, that kind of stuff. Brilliant, lots of hands. And who here would like to work on those? Who's perhaps not working on those already? So some more hands. Excellent, good. So that's good. You're hopefully this is going to be interesting. So I wanted to start with this quote. This is from an analyst called Benedict Evans. He's works for Andreessen Horowitz in Silicon Valley, and he's a smart guy with a knack for phrasing things nicely. And he said, my grandfather probably could have told you how many electric motors he owned. There was one in the car, one in the fridge, one in his drill, and so on. My father, when I was a child, might have struggled to list all the motors he owned, how many exactly are in a car, but he could have told you how many devices were in the house that had a chip in. Today, I have no idea how many devices I own with a chip, but I could tell you how many have a network connection. And I doubt my children will know that in their turn. Now, I mean, there are lots of people here, obviously, are both working on and owning connected products. So we're kind of probably, we're getting there as a group of people. I think there's still a bit of a feeling that some of the connected products that are coming out, particularly on the consumer side, are a bit of a novelty. Perhaps some of them, Wi-Fi kettles, that kind of stuff. We're still figuring out how to make this stuff, perhaps as useful and valuable as it should be. But my point for showing this was really just to show that this is something that's in the process of becoming a normal part of life, whatever kinds of mistakes we went along that we make along the way. Some people talk about IoT as this is like magic, and that's like, I really don't believe it's magic at all. I think magic is something we don't understand and can't control. And what's much more interesting to me is how we get this stuff to feel normal. I think that's a much bigger UX challenge. Now, it's kind of obligatory, I felt, because I was the first speaker, and I'm going to talk about IoT, that I should do the thing that people do when they do talks about IoT and show you some use cases. And because I know that in Germany it's much more common to talk about Industrie 4 rather than IoT, I felt obliged to show you some industrial use cases as well. So you may well be familiar with some or all of these things. But we're putting connectivity and computing in all kinds of applications in terms of things like, mundane stuff like monitoring whether concrete is under stress, whether train axles are damaged and the trains are at risk of derailment, farming, tracking pigs, knowing which bits of your farm need watering the most, all kinds of things. And that's where the strongest business cases are, frankly, right now. A lot of my work has been on the consumer side, so the examples I'm going to show you today will be more kind of consumery. I will talk about thermostats because I've spent a bit of time working on thermostats. I will talk about lighting because I've worked on that as well. There's also things like dog tracking, finding parking spaces, weighing yourself, controlling your front door lock. And one of my favourites is on the bottom of the far right is. These are the Proteus ingestible pill sensors, which when they make contact with stomach acid, send a little message to a Bluetooth patch on your arm so you can track whether someone's taken their medication. So there's loads and loads and loads of things, lots of very interesting applications. We're just starting to discover these. Now, when we talk about IoT, when you read about it in the press, very often it's sort of accompanied with a picture a bit like this. It's very shiny. It's often a kitchen. There's often a fridge in the middle of it, that hoary cliche of the internet fridge. And all of the things are kind of magically interconnecting and coordinating and anticipating your needs and knowing what you want for dinner and ordering the shopping and all of that kind of stuff. That's not really where we are. And a big part of the UX challenge, I think, at the moment, is actually dealing with the fact that that's not where we are. The reality is often that in putting connectivity and computing into things, we're actually also not just enabling new things, we're also creating new ways for them to break. Now, this is from a review of the Wink home automation system. So came out in the States. And this was from a review that was largely the reviewer was very excited about the fact that he could turn his lights on and off from his smartphone. Okay, all right. But it contained this line that said, well, it's a bit glitchy, by which he meant that sometimes the smartphone app would tell you that the lights were on when they were actually off. And sometimes it would tell you that they were off when they were actually on. But that's okay, because you're in the room at the same time, so you can see whether they're on or off. Now, if you want to make a really, really shitty light switch, you don't need to use the internet. You can just there are easier ways to do things like that. So, I think there's a lot of this stuff doesn't necessarily quite work the way we want it to. And, all right, the lighting example, that's kind of a bit trivial, isn't it? But in other situations, things like, medical monitoring your blood sugar if you're diabetic, monitoring, a baby who perhaps is at risk of breathing difficulties to see if they're okay, controlling your front door and who can get into your house and when, or even controlling your Tesla from your Apple Watch. These are things where being a bit glitchy could actually have quite serious consequences. So, we need to do better at this. And the other thing I wanted to start with was say, well, when we talk about design for IoT, I think people very often focus on the kind of very visible parts of that, visibly designed parts. So that might be the industrial design, things like, the Nest thermostat was one of those kind of early iconic devices that showed us that things that had looked beige and boring and plasticky in the house didn't have to be like that anymore. They could be nicely designed objects. And we also talk about UI design, so whether that's the sort of visual UIs in smartphone apps, or whether it's things like the different types of UI, like the Alexa for the Amazon Echo. I've just got one of these. It's just come out in the UK, and at the moment it's acting as a very, very expensive light switch, but it can do more than that. That's great. I think the point that I'd like to make is that it is possible to do a good job of creating nicely designed objects, nice apps, nice UIs, apparently sort of what look on the surface like nice UIs, but also for that not to result in a product that hangs together very well. And so these are some things I'd like to talk about today. I believe very strongly that designing the parts separately, which is often what happens in industry, doesn't necessarily result in a great user experience. And we have to get, as designers, we have to get better at thinking about coherent UX for the whole system. Now, there's a reference here to a paper which I'm leaning on. We lean on quite heavily in a chapter of the book, and for this, and I'll tweet that later because it is really good. This is how I think about UX for IoT. There are a bunch of layers or facets, if you like. And there's a very visible stuff at the top, so the industrial design of the devices and the kind of the UIs of the apps themselves, and interaction design, which is related. It's not quite the same as UI in the way we talk about it now, but this is all the stuff that the user interacts with directly. But underneath that, there's a bunch of other thinking that has to happen about how these things work together. So there's interusability, which is about interactions with spanning multiple devices, perhaps with different capabilities. There are conceptual models, designing how users actually think about the system. Underpinning all of that, there's also the kind of enablers that allow us to create those kinds of good experiences, which are not entirely digital. So there may be service design. A connected thing inherently has to have a service, an internet service to kind of keep it running. So that creates much more of an experience that the user has over time. And there might be non-digital aspects to that as well, such as user support, maybe installation, perhaps a business model that provides people with things that's not just provision of a digital service. So that needs to hang together as well for a good user experience. Then there's what I call productization. And that's just kind of how you take the technology and what you can do with it and shape that into a value proposition that people actually want and need. And this is where the kind of people like the Wi-Fi kettles and and the connected fridges and all that stuff, that's where that's going wrong, because these are not necessarily solving particularly pressing problems that people have. And if people don't understand why they should want something, well, you haven't really got much chance of doing a good job of this stuff. And then at the bottom is what I would call platform design. And these are the technology enablers that allow you to create that product in the first place. So that might be things for a designer, such as, have I got the right APIs to be able to create the right user experience? That's not unique to IoT, but when you're stitching lots of different products and services and devices together, APIs become extremely important. And it's also things like the technology that allows different products to interoperate, that allow things to coordinate in smart ways. That's I think I've got some double mic feedback here. Anyway, I'll let you sort that. But that's a whole other area which I'm not going to touch on today, but it's very, very interesting stuff. What I'm going to focus on today is the sort of underpinnings of the system user experience. So how do we want users to think about the system, and what's it like to design for things, interactions spanning multiple devices? Okay, so the first thing you need to think about, if you've got a system, different devices, is which bit does what. This is also known as composition. This is about figuring out which user-facing functionality goes on which device. And these are, you're probably familiar with at least one of these. These are a pair of thermostats. This is the Tage heating controller, and this one is the ecobee. Both of these systems basically do the same thing, but the manufacturers have made very different decisions about how to distribute user-facing functionality across them. The Tage is basically a sort of more or less a plain white box. It now has a very minimal UI, tells you the current temperature, but basically all of the functionality has been offloaded onto a smartphone app. Now that's good in a way, because that keeps the cost of manufacturing the thermostat down, and it also means it's much easier to make changes to the functionality you offer the user or to improve the user interface over time. So that's good. This is the ecobee. This is basically a set of devices. There's a very full-featured thermostat on which you can basically do pretty much anything on the device itself. You can also do quite a lot of that on a watch, and you can do quite a lot of that on a smartphone app. So they've taken the decision that it doesn't matter whether you've got which device you've got access to, you need to be able to do everything. And that's nice in a way, because if your phone battery's dead, you've still got control of the heating. In many senses, this is to me more a better approach. But it does mean that the cost of manufacturing that device is higher, And it does mean that if you want to change functionality over time, it's much harder to do that because you've already baked a UI into some hardware. The second thing you need to think about, and the user needs to think about, is how the different devices connect. Now, products that do apparently very similar things can work in quite different ways. This is a Philips Hue, connected light bulbs. And this is a Lifex, which is also a connected light bulb. You know, they do exactly the same thing for you. This one is Wi-Fi and connects directly to the internet. These ones connect via a bridge device. They're not directly on the internet. There is a bridge which is on the internet, which routes all the instructions to the bulbs. And that matters. And it shouldn't matter, in a sense, if it's all working. But it does actually, the difference between those two things does have an impact on the user experience. And it's very common for lighting systems to have automated rules. So you might say, well, if I'm not at home, I want to turn some lights on at 8 o'clock to make the house look occupied. What happens if your home broadband goes down? Do your lights come on or not? Well, if you've got a Lifex system, the rules are running in the cloud. And at 8 p.m., that cloud service will not be able to get an instruction to your lights to turn on. So they won't turn on. If you have something like a Hue, the rules run both in the internet and also on the bridge device. So if it gets to 7:59 and the internet goes down, your lights are still going to come on. You just might not be able to see that from your smartphone. So, you know, that's a fairly small, you know, lighting, it's not the end of the world. But those kinds of models actually have quite a big impact. And so this is an extra thing that users now have to think about. And this is another issue you need to think about is to do with consistency. Now, consistency is one of those things we've been talking about for a very, very, very long time in HCI and, you know, and UI design. And it's a very easy concept to understand, but it's often quite hard to figure out how to apply it because you can't make everything consistent. You have to decide what is kind of appropriate level of consistency. And that's even harder when you're looking at a bunch of devices which may have quite different form factors and different UIs. What things need to be the same across those devices, and what things is it most appropriate to be different? Now, there's a lot I could say about this, but I think in summary, the absolute most basic thing is that if you have a function with it does the same function on multiple devices, you have to give it the same name. And that sounds ridiculously simple and trivial, but this is a thing that doesn't always happen. And one reason it doesn't always happen, and I'll use a thermostat example again, is because sometimes the devices and the apps are not developed at the same time. So somebody makes a thermostat and says, I'm going to call this feature auto, and then an app designer comes along and says, I don't think auto makes sense to people, I'm going to call it schedule. And then you have two devices with different names for the same thing, and you know, people don't understand heating systems very well anyway, and they don't know they're the same. So that's the absolute most basic thing to do. But obviously, you don't have to make a smartphone app look exactly like the hardware it's representing, because that's silly. So what you're aiming for with this, apart from basic understanding, is to try and make those devices and UIs feel like a family. So I'm using a tool called Nest again. There's some obvious visual similarities between the Nest app and the thermostat. The other thing that's nice, when you turn the bezel to change temperature on the thermostat, you hear a little clicking noise. And when you press when you adjust the heating from the smartphone app, which you don't do by rotating something because that would be silly, you tap some arrows instead, or you can tap on the screen, you hear the same clicking noise. So it just reinforces the fact that those things are part of a family. And the key challenge with all of this is that we don't really expect things to behave like the internet. So when you use the internet, when you use things like Skype, or you use the web, we have an expectation that sometimes those things will run slowly. You know, emails might be slow to download, or that they'll fall over. So Skype calls can fail. And we kind of know our mental model of the internet allows us to sort of work around that and to some extent. But when you put those things in the real world, what happens is you get stuff like light switches that don't work, or that take kind of 15 seconds to respond to you. And because we have thousands and millions of years of evolutionary experience of the real world responding to us immediately and reliably, that can feel really, really weird. I'm going to show you a video. This is me controlling some hue lights, first over local Wi-Fi and then over 4G.
Right, so now we're on the Wi-Fi. Opening up the app. There we go, turn the light on. And it's all worked beautifully. Turn it off.
That was quick.
Yeah.
Right. So let's disconnect from the Wi-Fi.
And go again.
So we're over 4G. So this is now going via the internet.
Mm-hmm. So much slower.
Not worked at all. Come on. Here we go.
Okay, so it's not, it's not earth-shatteringly different, but hopefully you saw that there was a little difference in that delay, and sometimes that delay over the internet can be a lot longer than that. The other key issue is that a lot of connected devices run on batteries, and maintaining an open network connection uses a lot of power. So very often, a lot of things, we're used to working with phones and PCs, which are connected all the time, and not being connected is a kind of failure state, it's an edge case. Many connected devices are actually designed specifically not to be connected most of the time. They might check into the network when they have data to send or to look for new instructions. And so sometimes you get parts of the system very often will take time to connect and sync, and very often different devices will not necessarily have the same idea of what the state of the system is supposed to be. I had a video I won't show you I'm afraid I can't show you now for the sake of time, but this is another heating controller. I'm sorry, I spent a lot of time working on these things. And this one runs on a battery. It checks into the network round about every 90 seconds to 2 minutes for updated instructions. What that means is, if you're standing in front of it with a phone and you adjust the temperature, there might be a lag of 1.5 minutes before you see the temperature change actually reflected on the device, which means there's 1.5 minutes where these two things are telling you that the system is doing different, giving you different information about the system, which is quite fundamental kind of usability issue. So we have to find ways of working around that as well. And I'm afraid this is quite a long video, so we'll have to skip that. But these kinds of delays and glitches might seem fairly trivial, but actually they can sometimes massively undermine the value of the product. This is a Ring doorbell. It takes about 20 to 30 seconds when someone presses it to connect to the cloud service and contact the other version. This is version 1. They might have improved it now. But someone I know has one of these. You press the button, 20 or 30 seconds later, it connects to the cloud service and tells the person that there's someone at the door. Now, the average courier does not stick around that long, and couriers are a big part of why people want these things. So, this is not actually a particularly useful doorbell because by the time it does what it's supposed to do, the person's given up. So the challenges with this, there's a bunch of challenges for UI. This affects what we do with UIs, and it actually affects quite dramatically some of the assumptions that we make when we design. I'm going to talk about visual UIs today, but it applies to others as well. What we've tended to assume is that when you press a button and you see a state change, that state change is both confirming to you that you pressed the button and also confirming that your action has been executed. But when you've got these kinds of delays in the system and possible glitches, maybe that thing isn't going to happen. It becomes you have to factor that into how you design. So we have to learn to handle those delays and uncertainties much more gracefully. We can engineer some of them out. We can't engineer all of them out. And there's two things you can do here. And the first one of these is to lie. User presses a button, pretend it's worked, and backpedal and say if it doesn't work, you go back and go, oh, sorry, that couldn't work. We're skipping over the diagram. Sorry, I'm running a bit late. Instagram do this. If you like a photo, it's instantly shown as liked. It's not liked in the service yet. That message is still being sent, but you're just liking an Instagram photo. It's okay if it's okay. They'll tell you if there's a problem. You may have noticed in the video that that's what Philips Hue does. If you dragged one of these sliders up, for some reason that message didn't go through, and Hugh just kind of like dragged it back down again for me. So I've done that. Oh no, actually I haven't. You know, it annoys me greatly because I think that's quite rude. The other option you have, but sometimes you know it's lighting. You don't want to. It's okay. That's not the end of the world. The other option you have is to be quite literal about what's happening. And this is this is a very subtle approach with the Wemo smart plug takes. If you turn a switch off or change the state, you get a little interstitial state, and then when it's confirmed that your action has actually been executed, you get the state that you want. So that's nice and elegant. This is Lowe's Iris home automation system. It's a US thing. This is extremely literal about what's happening. So you press a button that says, sending changes, please don't exit, and then you wait and wait, and then it tells you that it's done the thing you wanted it to do. And the reason they do that, I think they've made it a bit more elegant now, but the reason they do that is because this system also runs emergency care alarms. And it's really important if, you know, grandparent or an older person has fallen over and wants to summon help, that you don't give them the impression that help is on its way until you're absolutely sure that it is. But it feels pretty clunky when you start applying it to things like, you know, water heaters and lighting. So my takeaway is really, you know, that the key thing here is not just about designing the UIs, not just about, you know, isn't it exciting that we now, those of us from software backgrounds, now get to think about hardware as well. You really need to think very hard about the interconnections and the experience of the system as a whole, because that has a massive impact on not just, you know, is this a pretty app, but the distinction between, is this a useful product? Is it a nice smooth experience, or am I confused by it? Does it feel like it's broken? I'd like to leave you with a quote. This is from Larry Tesler, who used to be a VP of Apple, who came up with the law of the conservation of complexity. And I think, if anything, my kind of takeaway about designing for IoT is that what's exciting about it is not just kind of new UIs and we get to play with hardware. It's actually how complicated a problem set it is to get this right. I've only touched on some of that today. Anyway, but Larry Tesler said, as you make the user interaction simpler, you make things more complicated for the designer and the engineer. And working on connected products is, you know, more complicated for both. Thank you very much.